Hi everybody, this is the fourth lesson of the Permutations and Combinations chapter. It's lesson 1.2.2, and in this lesson we're going to talk about permutations, specifically the nPr notation. In the previous lesson we took a look at how you permuted n objects if you were going to use all of them at once here. Now what we're going to do is focus our attention on a problem where we're permuting r out of n objects. And the notation we use is nPr, and we interpret that to mean n factorial divided by n minus r factorial. Well, the easiest way to illustrate how this works is to just do a question here. So let's take a look. How many ways can we permute just 4 of the letters in the word province? Now, the first thing we need to do, if we're going to use the permutation notation, is identify the variables. There are 8 letters in the word province, and so n is equal to 8. But we're only going to look at how to permute 4 of them, so r will equal 4. So we'll write this as 8 permute 4, or some people say 8 pick 4. And going back to our definition of permutations, we know that we would then write this as 8 factorial divided by 8 minus 4 factorial. Now it's simply a matter of plugging this into our calculator, and we see relatively quickly that this is 1,680. So there are 1,680 ways of taking 4 letters from the word province and determining the number of permutations. Now let's look at another question. How many ways can you assign the positions of president, vice president, and secretary to members of a 6-person committee? Now it's not always obvious that this is a permutation question, but in this case it is because we're assigning positions. If you change the positions, then you change the makeup of this group here. Just ask the president. If that person wasn't the president, that would be a completely different group. So order matters here. So the first thing we got to do, just like in the previous question, we have to identify what our variables are. Since there are 6 people we're choosing from, n must be 6. And because the group that we're choosing has only got 3 positions in it, r is 3. Making a quick substitution into our permutation notation, we get 6 pick 3, which becomes 6 factorial over 6 minus 3 factorial. And that becomes 6 factorial over 3 factorial, which, when we go to our calculator, we see is equivalent to 120. So there are 120 ways we can choose a 3-person government from that committee of 6 people. Now let's take a look at a problem that's strictly algebraic in nature. N pick 2, or n permute 2, is equal to 56. And so our job here is to solve this equation and figure out what the value of n is. Okay, so to solve this, we begin with the initial equation that we're trying to solve, np2 equals 56. And then we're going to write the permutation notation in terms of the factorials so that it's in a form that we can work with algebraically. So we get n factorial over n minus 2 factorial equals 56. Now, since n is larger than n minus 2, we'll expand n factorial until we get to the n minus 2 factorial that's sitting inside it. We can then cancel the n minus 2 factorial that exists in the numerator and denominator, and we're left with n times n minus 1 is equal to 56. We can then multiply this out to get n squared minus n equals 56. And because this is a quadratic, I can bring all the terms to one side to set it equal to 0. And then, as you've done many times before, you'll factor the quadratic, and we get n minus 8 times n plus 7 equals 0. And so we see that the solutions to this equation will be 8 and negative 7. But because this is the Perms and Coms chapter, we don't allow negative numbers, and so the answer is just 8. Okay, now I know that we've already solved this equation, but I want to point out that when we get to the step n times n minus 1 equals 56, there is a slightly different way that you can approach it, and some of you might find this a lot more intuitive. Notice that on the left side of the equation we have n times n minus 1. What this is saying is that the left side of the equation is the product of 2 consecutive integers. Now think about the number 56. It shouldn't take long to come to the conclusion that 56 is the product of 2 consecutive integers, 7 and 8. Now, because 8 is the larger of the 2 integers, n must be 8, and n minus 1 is 7. Now let's look at another equation. N pick 4 is equal to 40 times n minus 1 pick 2. Now we've got to solve for n. So we'll start our solution by rewriting the equation. And then our next step is going to be to rewrite the permutations here in terms of the factorial notation. So n pick 4 becomes n factorial over n minus 4 factorial. And n minus 1 pick 2 becomes n minus 1 factorial over n minus 1 minus 2 factorial. For this next step, we're going to deal with the factorials. Now, first of all, notice on the right-hand side of the equation that the n minus 1 minus 2 factorial in the denominator became n minus 3 factorial. Now, on both sides, what we do is we look for the larger factorial, and that's the one that we're going to expand. So on the left-hand side, it's n, and on the right-hand side, it's going to be n minus 1. And then we start to expand those out until we find the factor in the denominator. Once we find those factors that are shared in the numerator and denominator, we can cancel them on both sides of the equation, and then we're left with this n minus 1, n minus 2, n minus 3 equal to 40 times n minus 1, n minus 2. At this point, you should notice that there are now factors that are common to both sides of the equation, in which case we can divide those out from both sides, and we're left with n times n minus 3 is equal to 40. Since this is now just a quadratic, we can expand the n minus 3 and bring the 40 over to get n squared minus 3n minus 40, which can easily be factored into n minus 8, n plus 5, giving us the solutions n is equal to 8 and negative 5. But once again, because we don't allow negative solutions here, we know that the answer can only be n equals 8. Now, before we finish this lesson, I want to point out that this equation could have been solved in a slightly different way once we got to the point n times n minus 3 equals 40. Notice that what this is saying is that the product of two numbers that differ by 3 is equal to 40. Now, think about 40, think about the factors of 40, and it shouldn't take you long to realize that the numbers are 8 and 5. Because 8 is the larger of those two, n must be 8.